Hello everyone. In this lab, we will be taking remote measurements using the total station. For this lab, we will require the following equipment: a total station, a tripod, a pogo with a prism, and a tape measure. Depending on your work site, you will require different levels of PPE. The minimum standard are good working boots for the appropriate conditions, a pair of gloves, and a safety vest.
Hi everyone, so in today's lab we are going to take some remote measurements, one to a fire hydrant and the other to the top of a building. But first what I will do is show you guys how to set up the total station. This is a little more complicated than the level, as there's a few extra steps. We also don't just set up the total station anywhere, it is set up over an actual point and it is level to the ground. So the first thing I do in setting up the total station is I put my instrument on the tripod, secure it down so that it doesn't fall off. Set up my tripod legs somewhere near the point that I want to be. Basically, what I'm doing right now is we've drawn a yellow X on the ground. This is going to be our point. Normally it would be a spike or a nail or some other kind of a benchmark that's a solid point. For the purpose of today, we've just drawn a yellow X. If I hold my foot down near that yellow X, this will help me position the instrument. Another thing that you can't really see, but through the bottom here, there's a little red laser that's pointing at the ground. That's called the laser plummet. In other total stations it might be called an optical plummet. This one we have a laser. I have one leg firmly planted in the ground over here. My other two legs here on the tripod, they're going to move easily. If I lift them, I'm going to put that little red laser dot in the center of my yellow X and then let the tripod legs go down on the ground. At the same time, I have tried to keep this plate here relatively level to the ground. It does not have to be perfect, but we like it to be as close as possible. That way we have less adjustments to do later. Now that my laser is in the center of the X, I'm going to stomp in the last two legs. I've already stomped in the first one. Then what I will do is, using the foot screws, I'm going to center that X to make sure it's close. So it is right now. The X and the dot are pretty close to center. I have another bubble on my instrument. What I'm going to do now is use the tripod legs to get that dot, or sorry, the level bubble as centered as possible. So looking at it, I can see that the adjustments that I need to do is I need to bring my level bubble kind of towards me. Using this tripod leg, I'm going to loosen it, put my foot on the bottom of it, and lift. And this is going to bring the bubble so that it is almost in line with my other tripod leg. I will tighten the leg now. I'll move over to this leg. Same thing. Keep your foot on the bottom of it to hold it in place. Loosen it. And then let it come up a little to help move that bubble. So in this case, what I can do is adjust this leg a little bit again. This one just has to be lowered now, even though I raised it before. Okay, so if I lower it and leave it there, my bubble is pretty close to the center of that circle. You'll notice that one thing I did not do, I did not touch the third tripod leg. When you're setting up a total station, you only want to touch two of the legs. The moment you touch the third, you actually start moving your laser plummet, which will throw your everything out of whack. So now when I look through this bubble, I see that it still needs a little bit of centering. We can also see it on the screen. The digital display readout is showing us where the bubble is sitting. Now I can use the foot screws on the tri-brac to center that. So if I turn for you to see here, you'll see that as I move the foot screws, there are some small adjustments happening. So just tiny little movements of the foot screws is actually moving that bubble, so it's really close. little too much. Okay, so now we got check marks on all three sides. The next thing we do is we look down at our laser, and we'll see that our laser has moved just a little over the yellow. So what we do now is we loosen the screw at the bottom of the total station, making sure not to rotate the actual total station, but only move it in an XY plane. We are now going to move it so that that laser is centered on the yellow X. So it's just a small little movement, being sure not to rotate the tri-barack on the total station. My hand's in the way so you can't always see it. Now we're centered again. We will look back at our bubble. It might just need some final adjustments. We have our three check marks again. We look down, our laser is still centered on the X. We are now set up and ready to take measurements. Okay, now we're set up on our points, and we're going to do some remote measurements to find out how far the fire hydrant is from us without actually going to the fire hydrant. So I am set up on point 1. Riz is on point 2 right now. I am going to measure to him to find out my angles and distances to him. So just remember, when you're looking at the prism, always do your horizontal sighting to the bottom of the prism, and then rotate your scope up to get the actual prism. But in order to set your horizontal angle correctly, you should always sight to the bottom of the pogo. Okay, so now I'm measuring. Okay, so in these situations, what you'll do is you'll record your horizontal angle, your slope distance, and if you want, you can also record your vertical angle. Sorry, we do need to record our vertical angle because we need our horizontal distances. This instrument has given us the horizontal distance to Riz. We like to record the slope distance just in case there are any errors. So at the moment, my horizontal angle that I have is 101.1656. My vertical angle is 0.3518. And I just scroll down a little. My slope distance is 30.154. So now what I'll do is I'll turn my instrument to look over at the fire hydrant. I'm going to sight the nut that is on top of the fire hydrant. This is the same nut that we would have used in Lab 1. So I've now sighted that. Just scroll up a little. My horizontal angle has now changed. Now my horizontal angle is reading 5.82720. My vertical angle is 0.0034. I have no distance reading as I don't have a prism there, so I can't measure the distance. And that is what we are going to do in this lab, is figure out what that distance is. So that's the measurements for point 1. We are now going to move our total station to where Riz is, and he will come over to us. Okay, so now we have moved the instrument over to point 2. Riz is set up on point 1. I will backsight Riz, take a measurement to him, and then turn over to the fire hydrant. So again, remember, when sighting on the prism, sight to the bottom of the pogo first. For your horizontal angle, turn up. Line up vertically on the prism. and then measure. Okay, so I have my measurements, so I'll now record them. My horizontal angle is 274, 0911. My vertical angle is reading negative 01931, which just means that would mean that there's a setting in the instrument that should be changed so that our vertical angle is actually reading a number between 0 and 180 and not a negative number, but that's okay. Our slope distance is 30.153. Now we will turn to the fire hydrant and sight on the bolt on the top. Okay, so with my instrument sighting on that, we will now go back and read our angles. So our horizontal angle is 339.1045. The vertical angle, again, it's a negative 03721. And we do not have a distance measurement because we don't have a prism over there. That's everything you do for the field portion of determining the horizontal distance of an object from you that is remote and you cannot access. Now you can go on and finish the calculations for this lab. What we're going to do now is move over to one of the buildings, and we're going to do a remote observation for a vertical distance in order to determine the height of a building in relation to the ground level. Alright, for this portion of the lab, we are going to determine the height of the NREF building in relation to the sidewalk just outside the doors on 116th Street. For this type of a measurement, our total station just has to be set up level. It doesn't need to be set up over an actual point unless we are trying to carry elevations forward. But we'll cover that in later labs, how to carry elevations. Right now, we just want to know how high the top of that building is above the sidewalk that is right outside the doors. So I have my instrument set up. Riz is set up with the pogo and the prism right against the wall. We are going to take a vertical angle measurement to him and a slope distance measurement to him. We will then move the telescope in the total station. We'll angle it upwards and look at the top of the building. So the first thing I'll do is I will sight on him. Okay, so I am now looking at the prism. Though one other piece of information we do need to know is that the height of the prism right now is 1.600 meters above the ground. You will need that in your math to determine the height of the building above the actual sidewalk. So now I can hit measure on my total station, and this will give me my slope distance. So the first thing we want to record is our vertical angle. The vertical angle reading we have is 14538. Scroll down to our slope distance. The slope distance is 47.518 meters. Now I'm going to plunge the telescope so it's pointing upwards. I want to keep my instrument relatively the same horizontal. I don't want to change my horizontal angle. This is because we are basically perpendicular to the wall right now, and we want to go straight up the wall. So turning the scope, looking upwards. One more. And now I have my crosshairs right on the edge of the building at the top. My vertical angle has now adjusted. The vertical angle is reading 3745 0.25. We now have enough information to determine the height of that building above the sidewalk.
When surveying, always be mindful of your surroundings. If you are working around roadways, be aware of vehicles. Never step out in the road without checking for vehicles. Try not to set up your instrument on sidewalks where pedestrians may accidentally hit your tripod. If you are on a construction site, ground vibrations can cause errors in your readings. Be sure to always wear high visibility colors and any other PPE that is required.